Thank you for giving me this opportunity to be with you. As a country, we've always been followers, unfortunately. We've done something that somebody else did not want to do. And for a change, I see this trend changing. When I was part of the team that built India's first supercomputer, we could actually foresee the fear in the West, and they were so worried that we will build that capability and then they will lose that capability. I see that transformation happening. My brother trains Americans today. Earlier they would say, we will train you Indians. My brother trains Americans today. They wake up at 4 in the morning to get trained by him. Okay, so that's the shift that's happening. So the world is waking up to that, and I teach user experience design, usability, and I believe that as we go to the future, if you look at the trend and be prepared to be on top of the trend, rather than allow the trend to buckle you, then we will take our rightful place in the nation, in the world of nations, right? So what's going to happen, and we are seeing the trend. So I'm going to give you examples of the trend. I'm going to help you understand what are the challenges the testing community is going to face 2015 and beyond. Okay? Because what the Americans realized, even though they initiated the computerization and mainframes and so on, soon all those skills became not so useful. They had to learn newer and newer skills as things moved to the cloud, things became smaller, all of these things. So the skills need to change. So here we have an opportunity now. If you know what's going to happen just 2-3 years from now, it's not like future is 10 years away. No way. In 10 years you'll have flying chairs. 10 years is really far off. 2 to 3 years you're going to see this change happening. So I'm going to start by, how many of you have actually experienced these things called the Internet of Things? Okay. How many of you would like to see a small video on this? Because it shouldn't be boring. Oh, I've seen this already. So let me play that video first, and then I'll start my talk.
Over the past century, but accelerating over the past couple of decades, we've seen the emergence of a kind of global data field. The planet itself, natural systems, human systems, physical objects have always generated an enormous amount of data, but we didn't used to be able to hear it, to see it, to capture it. Now we can, because all of this stuff is now instrumented, and it's all interconnected, so we can actually have access to it. So in effect, the planet has grown a central nervous system.
So there's about 1 billion people using the internet at the moment, and that's set to grow to probably 2 billion in the next couple of years. And we think that's quite a lot, but over the last 10 years I've been looking at devices being linked up together using networks, so sensors on things, these temperature sensors and traffic sensors and flow rates of water and how much electricity you're transmitting data.
Okay, it's happening now as we speak, but it's still a little more, I would say, the exception rather than the rule. 2015 and beyond, it will be the rule. I'll give you a simple example how a senior of mine from college, based in Bangalore, from your place, from Andhra Pradesh, he's built chips. Right? I'll show you some samples of those chips as well, which has a built-in battery. And this chip identifies the, I would say, I don't know what that word is, but how much water is there, water content in the soil. Okay? And it also has wireless capability to communicate this information to a server that can capture this information. So how is he using it? Suppose you have a 100-acre farm and you have a lot of trees, saplings that need to be watered, right? There are 2 ways you can do it. Put a lot of employees and constantly keep watering it. And half the time the water is not used, because even if it doesn't need, you're putting the water. And the intelligent way to do is to put this chip with every sapling, okay? And the chip will then communicate through the server, and if you build an SMS server in that, it will tell you by phone, hey, I am plant number CR210, I am feeling thirsty. Right? So then you go and only put water to the plant that is thirsty. Go one more level, he has integrated a drip irrigation system for every plant, and he doesn't need to be there at all. Every time it's thirsty, it asks for it, a pipe opens up and only that plant gets the water. So a lot of economy of water, no labor supervision, and that chip, the battery will last to the extent it's needed. Right? So suppose you're putting some thing which lasts for 3 months, a plant comes up in 3 months and goes away, then you don't put a 3-year battery in it. You put a 3-month battery in it and it's gone. If you want, it's going to last for 1 year. You need to take care of a sapling for 1 year. After that, it's on its own. It's fine. So put a battery for 1 year. Right? So in practical day-to-day life, slowly some of these equipments are becoming relevant. Okay. So I'll give you some. If you look at Three Idiots thing, definition kya hai? Started in 1909. Kevin Aston, he wanted something called an auto ID center. Everything is ID. So you should be able to understand who, what, everyone is an auto ID. So one of the end result of that was something called RFID, which all of us are used to. Right? It's also called as machine to machine, M2M communication, or pervasive computing. That means computers are there everywhere. Now, what is it that you're seeing in today's world? You're seeing NFCs, right? You're seeing a lot of, things. For example, payment. Slowly, the credit card can go away if you have a secure NFC device connected to your phone. So that becomes, NFC. Barcodes. This is there for decades now, and you're seeing that. That's also a sort of an example of Internet of Things. Digital watermarking. QR codes you're already used to. They say by 2020 there will be 30 billion devices and the market will be approximately $2.5 trillion, this market of Internet of Things. So why is it going to explode? Because of this concept of economies of scale. As long as it's expensive, people are not going to go for it. But when you find today, I think those of you who sat through Professor Kothari's class saw that the labor cost is what percentage higher than the cost of the computers? Thousands. Same thing. Those of you who are going to your villages, please find out how easy is it to get a laborer today to work in the fields. I go to my native. The only people who are working are 50 plus. None of the youngsters are working in the fields. So what's going to happen? You're going to stare at a food shortage. No laborers, then what are you going to do? You're going to only eat canned food. Not going to work. You're going to fall sick very fast. So there's no doubt that you need to continue to grow plants and do that, what has been happening for thousands and thousands of years. But what do you do in the new context where it doesn't make economic sense to have a lot of laborers? If you have no choice, if you have a choice, that's the best. But if you have no choice, then when there's large scale requirement, the price falls down and then it becomes part of day-to-day life. Would the mobile phone be in with every single person in India today if the price was at 10,000 rupees? It wouldn't be. Second hand you get for 500 rupees. Every other person in India has a phone today. And because of Chinese manufacturers, smartphones are available at 2,000 rupees. Smartphones. It won't be too far off before anybody and everybody will be having a smartphone as long as you make it simple and usable for them. So economies of scale is going to drive the Internet of Things, and it's going to happen, it's going to be a reality. So every equipment we use could be connected. You forgot to switch on the washing machine, no problem. It's connected, it's online, so you can just go switch it on and, and then maybe in the future, right, it'll get integrated, not the way it's standing alone, it'll get integrated to a drying machine automatically, or it'll get something else, because people will have to think out of the box now. When it's controllable from far, then you'll have to start thinking out of the box while building these equipments, right? FirePro Systems, a friend of mine is the CTO of that. If you go to Indiranagar, Bangalore sometime, you can actually have a demo of a future home. Right from the time you enter, everything is on your fingertips. Light bulbs, the switching off the lights, the air conditioner, it's all just one handheld remote. Right from opening the door to switching on the lights to switching on your gas stove to switching on the geyser, everything is just one device. Now that one device could be a phone, it could be an app on the phone. Right? And that is still one step before the Internet of Things. Eventually, systems thinking and communicating to themselves is the true Internet of Things. Okay? So some basic fundamentals, it's a gadget connected to internet on its own or via a base station. It has a processor and it has a sensor. Okay, so the sensors could be for different elements of human factors. What are the human factors? The 5 elements: something to see, something to smell, something to feel, the temperature and so on, right? Something to taste. So any of these which get converted into a transducer or a sensor becomes part of this Internet of Things device. The standardization, and that's where the testing part comes in. Because the moment the data communication, all of these things start getting standardized. For example, all the car manufacturers are working towards this now. There's a standard, just like medical devices have a standard. So there is a standard now for communicating with your car, because the last 70 years, most of the car is stabilized. You know, it's got an engine that gets heated up. It's got a lot of other controls which are sort of standard. So now they're connecting electronically with codes which you can use your Bluetooth device and communicate with your car. E2O has already done that. I don't know if you've seen some ads. How many of you have known of the E2O car from Mahindra? Right? If you don't close your door, you lose something, you get an SMS. It's got an integrated, chip, SIM built in, so it starts communicating to you. So standardization will stabilize and scale up the market. So as people are going to build standards, those of you who are going to be passionate about this, be in touch with the standards, become experts at these standards, and start putting teams that can test to these standards. So installed base as of 2009 of connected devices, it's going to go to more than between 25 and 30 billion by 2020. A lot of studies done. This is by Indians working in a European university, a person by the name of Gubbi. He's found examples in every single thing that our lives are connected with. Whether it's defense, remote monitoring, the smart grids, retail, factories, communities, transportation, emergency services, parking. How many of you have been to Singapore? Okay, so have you seen the way it's mandatory for every car to have an onboard device, mandatory, right? And the onboard device can be charged in any stationery shop, supermarket, anywhere. And any road that you go which is toll road, it automatically minuses that money from that onboard device. So you don't have to, wait in the queue and pay the money and all that. And every parking lot that is there, it automatically times the time you came and parked and took your car away, and it minuses the parking fee. If you look at parking and traffic, the moment you have these devices and it's integrated into it, like you have a place like say Abid's, very difficult to park there, right? But if the space, everything is automatically recognizing your car because the car has a device, right? And you go and park there and it minuses that amount. Okay, you will be very careful because it's going to charge 4 times the normal parking fee because it's a very busy area. That's what they do. Like peak hours in Singapore, the same thing 4 times it gets cut. The toll fee is 4 times the normal. So you'll start thinking twice. Unless it's really critical, you won't drive that way in the peak hour. So there are a lot of things that can get integrated into your life and to live in cities. Like the talk, if you heard, he said a lot of people are now living in cities, and that's a foregone conclusion. You can't reverse it so easily, the trend. It will take some time to reverse the trend, right? So in every single field, you will find that devices, equipments, there's going to be a fight. A lot of companies are going to close down because they're not able to live that fight, but standardization will start happening. So this is what we find as the technology roadmap that will happen, right? So right now we are here in the supply chain, vertical chain applications. So you can find that miniaturization, power efficient electronics, that's what's happening now as far as technology. Okay? And slowly, within the next 5-6 years, you will find this word called ubiquitous positioning. That means almost everywhere you will find the effect of advanced electronics or gadgets which are smaller and smaller, which have an intelligence of their own and which can be controlled, which can be communicated to, and which communicate to you. It started happening in a slightly bigger way, but you will find it happening in a smaller way as well. Like I'll show you examples of devices now. So now see, there is a group in the Washington DC area, the capital of the US. called the Internet of Things DC area group. So they meet regularly. This is one of the indications that, wow, it's going to come now in the next 2 years. Because when people start meeting and then starting to discuss and so on, this is what happened when the web started. People started meeting up. Even in the US, there's a difference between the Washington area and the San Francisco area. They say the San Francisco area is a couple of months ahead of the Washington DC, the East. So this is what is there in the East Coast. They're talking about devices, sensors, networks. They're talking about embedded software and apps, data collection, how to do it from the cloud services, back-end processing, user apps and front ends. What are the business opportunities? What are the security and privacy issues? So they're discussing these things. So they're going to start making and working with the international community to start defining standards. Those of you who are going to be passionate and want to work in this, start being part of these groups. Start contributing. You say, give your point, fine. You can voice your opinion. Maybe you will have a better idea than them, and they're not going to be close to getting ideas from you. So become part of these groups. This is the West Coast. And the West Coast knows that most important than everything else is the first one, usability. Unless you really make it simple, it's not going to work. And so that word, the origin of this field in HCI or human computer interface was Donald Norman. And the first book he wrote was The Invisible Computer, right? And now that is becoming a reality 3 decades later. We believe products must be as invisible as possible to enable us to do more while not taking away from our lives. So this is the group that's meeting in SFO, iothings.org. There are about 7-8 companies which are pushing this movement there. Open data. You had talk about open source, open data, a couple of sessions ago. Interoperability. This is where the standard setting will happen. And the last and maybe the most important, because for whatever you say, the world is still not a trusting place fully. Okay? We wish it was. It's not yet. So it still needs a lot of checks and balances to make it a trustworthy place. So security is as important or more important than a couple of things as far as Internet of Things is concerned. ThinkSquare is a Swedish company, and they've built an operating system called MIST. And Europe's biggest chip makers, STM Microelectronics and TI, which you're all aware of, it's very famous in India as well, Texas Instrument, they have started building devices for Internet of Things. So they have teams now set up, they're working in stealth mode. Google is working in stealth mode, Apple is working in stealth mode, right? Because Google and Apple and even Microsoft, all these three, they don't like to be standardized. They want to set the standards themselves. And because they have large volumes, they believe that they will be able to do it. Maybe it's true, but you never know. You never know. Somebody else can come and pull the limelight the moment they make the first 4 things work: usability, openness, interoperability, and security. If they adapt to these 4 things, it's possible that somebody else will steal a march over the giants. Okay? So this is one example. A tag. It's from a company called Treehouse Labs. Okay? And it's the size of a car key holder. And it's got a tag. So you can tag it to anything. And it's got a radio-like device. So the range is about 800 feet. And it's got an iPhone app. So you can, access, control, and so on. Right? But the problem is the battery. It lasts about a week or 2 on charge. And it can be charged like any other USB device. You can connect it with a cable to your laptop or to any other device which has a USB charger. And it works that way. So a lot of people are using these things, especially the absent-minded professors, right? They don't know where they're keeping their things and so on. So they're tagging it and calling it something. And so wherever they want to find it, they can just find their phone and then ask for the phone where it is. And it makes a beeping noise and you can go and search and get this device. It's also useful for, now I would say Indian women to tag it to all your gold. So it won't get robbed, It's very difficult to break it. And the price of gold is so much that, just a chain may be costing about a couple of lakhs today. Okay, this is a little more advanced thing. It's about $20. It's called the Chirp from a company called Garmin. It lasts for a year on a phone battery. The CR2032 is what is there in your watches, a watch battery. But they made it cheap, but it works right now only with a handheld device which costs $300. Right? So therefore, unless it's it's like a large factory and a lot of garments all around the place, each being $20. But that main device controls many such devices, it works. So eventually somebody is going to break it, maybe the Chinese. They'll make duplicate copies and you can simply use it with maybe your iPhone app, not a $300 specially designed device for this. Then there's another one which is already being used with your Nike shoes, right? You have the Nike Plus sensor, so they put it inside the shoe and it tells you how many kilometers you walked and it starts giving you feedback and so on. So you can put it on, so right now it's being used. This is like, in one sense, in the sports arena, this is being used. Now, the advantage is that, this is, it can transmit a lot of data. So therefore, if you're able to use this in equipment that needs to transfer a lot of data regularly, then this protocol can be used, right? So again, a lot of work happening in this area, again in California. Now, what are the challenges, that the industry is facing when it comes to building these devices? One is manufacturing, right? So the more smaller you make, economies of scale is very important. Like I head the operations of Sony. We make the world's toughest mobile phones and we get it manufactured in China. Now, the requirement for rugged phones is not very high in the consumer market because the price of a normal phone is so less that if it breaks, I'll buy a new one. Whereas in the field where it's absolutely necessary and saves lives, it's mandatory. People buy it because it saves lives. Now, therefore, the volume is not large, and therefore we find that when you want to build a phone which is exactly like any other phone, but which is rugged, which can withstand high temperatures, high pressure water, can be in water ice cold, it can take fire, and all of that, you find that when you try to manufacture it and so on, the value is much higher. Because you're not giving 1 million, 2 million orders. You're saying, I want 200,000. I say 1 million and above, the value is going to be much lesser. So when you start small size manufacturing, now unless you've done a great job of it and you got a big pending order, you can end up making a loss as a company. When you manufacture that and then you find that there are no takers for it. Right? So the small size manufacturing, because if it's larger size, then people are willing to give it to you in lesser numbers. The more smaller it becomes, more difficult to manufacture, the more economies of scale, large. Second is that, okay, technology will keep changing. So how do you upgrade such a thing? Or do you need to upgrade? Or do you design it use it for 3 months and throw? I used to, buy from a footwear retailer regularly. And it would last me a year or two. One of the footwear I bought lasted 3 months. So I went back and said, what's happened here? What did you do? Sir, I was not getting enough business. Whatever I was selling, people are coming to me only once in a year. So now I've deliberately made it such that in 3 months I'll be forced to come back. Now I said, I don't know. I'm not sure whether that's a good logic. Because people came to you because it was lasting a year. And now you're deliberately making it spoil. That's the Chinese model, right? So you make things and you know for sure it won't last for long, but it's cheap, so you'll buy it, right? So upgrade becomes a challenge. How do you design so that it's easy to upgrade or maybe it's easy to maintain? Reuse also, right? Because electronics can cause a major waste problem if you're not able to reuse. So, even though this senior of mine has gone and put chips in the plant, I don't know, long term what are the environmental effects of that after it's done, right? So there has to be some, right now there is no policy, but they will have to come with a policy soon, an e-waste policy. Those of you who are interested, you just say Pacific Ocean, I think garbage it's called, just do a Google search. And I don't have time for you, I have that video with me, but you do a Google search and see that video. The size of Karnataka, Tamil Nadu, Goa and Andhra put together is the size of the waste on the Pacific Ocean. There is one island of that size. Because of the currents, all the plastic bottles, the waste that we throw and reaches the ocean, whether in India or America or Japan, is going into one place between America and Japan, and the size is that size. There's only plastic waste there. So this person is saying, please stop doing it. After some time, it will grow and it will start reaching the shores. And already thousands and thousands of aquatic animals are dying because. So this reuse concept, becomes very, very important, right? And people, commercial entities will not bother about it. But socially relevant organizations, NGOs, governments should push and see how we can really, make it what I would say environment friendly. The second part is energy. I give you examples. It lasts for 2 weeks on a charge. Another one lasts for a year. So energy becomes very important. And if you can make it self-sustaining, working on the energy of the neighboring thing or some physical thing or solar, then that's another additional advantage. So efficiency of energy as far as Internet of Things is concerned. Optimal data collection and transmission. Take your own example. Okay. You start collecting a lot of things, say newspapers, magazines, this one, that one. Then suddenly 3 months later somebody asks you for something. Since you have collected a lot of things, to try and find that one thing that you want, biometric system. Right? So I told my IT manager, just collect the first in and last out. Don't collect any of the data. He says, no, what if they go for chai and not come back for 1 hour? What if they, all this. I said, see, you're going to come back to me in 3 months and say, there is so much data, I want additional hard disk, I want additional processing power, I'm not going to give it to you. And this is exactly what happened. He had done the settings to capture every single, you go outside it will capture, you go inside it will capture, some friend comes, you go, you come out. So keeps getting, so you'll get lots of data. So the data keeps going bigger and bigger and bigger and you don't need it, right? If you're going to make sure that it's like a prison, then your people won't work for you. I said, we are not working that way. We only want it for the stupid government because they have a labor law which says you have to have attendance and you have to have a form T which you have to print out every month and get it signed by the head of the department and submit. I want it only for that. So first in, last out enough. Don't do anything else. But somewhere this feeling that I want control. I want to know who went where for chai. Who's going to bother? Right? So then he came back 3 months later. I want a higher hard disk. I said, I told you, I warned you. I said, stop it now, delete all the other data and make it only first in, last out. It lasts you for another, at least 1 more year, 2 more years. So data, if you unnecessarily collect for the sake of collecting lots of data, your product is going to fail. So you have to work and see what is optimal, what is relevant and do it. Then secure and accurate. You can end up getting wrong data. And when you process wrong data, you will get wrong results, right? And when you get wrong results, you will do wrong decisions. And then, just like the film from Rajinikanth, Robo, then you will have the machines controlling us, right? All sorts of things happening and we won't know what things are going wrong. So, accuracy of data and fundamental principles of robotics never to be forgotten while designing machines talking to machines, right? Security and accuracy. Levels of safety in destructive environments, right? Because if you give too much of control to machines, right, you don't know how they will behave when they have been, what I would say, destroyed, half destroyed. Okay, I'll give you an example. For example, you put this chip inside the plant with the sapling. Now the root started growing and so on and so forth. And then somebody had a great idea to plant a metal pole so that the sapling gets some support. Now the guy who planted the chip and the guy who is planting the rod, 2 different people. So he doesn't know there's a chip inside. Doesn't it happen with all your workers here? They go and constantly break the water pipelines. Because the water pipeline division is different from the road division, is different from the electrical division, different from so many divisions. So they don't have that naksha, the design of the whole structure. So he will break that chip. What will happen now? Who knows? It's possible that the chip will say, I'm constantly hungry, and then this drip irrigation system will completely keep putting water, and in 24 hours the whole place is flooded. Why? Because this chip failed. So therefore, keeping in mind this is a test scenario, this could happen. So what should happen? You should put water, and in a particular day it should not go beyond this volume. Otherwise, you would never have imagined this scenario and would never have put this business rule while designing the product. Are you getting what I'm saying? So in a destructive environment, all possibilities you should eventualize or think about, make it as a test case and plow it back into the design of the product and the testing. Field testing is a problem because you could do the testing with you within the lab. Okay, but the moment, because Internet of Things is actually what's happening in the field, large scale performance testing, field testing becomes a very big challenge. So this is something that all you guys have to think about. Given anything and everything is going to be connected, how can we make field testing, happen, make it easy for us to understand and so on. And another important thing is getting the user experience right. Fundamental principle is those who design are 9 times out of 10 not the ones who use it. So you will find it very difficult to put yourself in somebody else's shoes to understand what is it that he is going to get from this whole exercise. I'll play a simple trick with all of you right now. So suppose there is this parking sensor. There is a parking sensor and it is there in every place where it's a place donated. Two-wheeler parking only. Okay, and there are parking sensors. And the moment you keep your two-wheeler there, it senses that your two-wheeler, it knows your number. There is a device on your two-wheeler which knows your number and it automatically does a timestamp. Now, if you had an Android or an iPhone or maybe a BlackBerry and you have an app on this, what is the word that you would expect to come on the screen saying that I have a lock? Have you seen the Avatar film? Yes or no? So there is this thing saying I see you and somebody is explaining what that I see you means. It doesn't mean that I'm seeing you with your eyes, but I have a lock. I understand what you're saying. I have that connection. So now you have this app which is an Android or whatever app, and you go and park your two-wheeler, or if it's a car space you park your car, your app lights up and gives you an indication that I have a lock. That means I acknowledge that your parking time starts now. So what is it that you would expect to come? So just think about it, and I'm going to ask, and let's see how many of you have thought of the same word. Because if many of you thought of the same word, it's very easy for user experience designers to do the word. Rate of charge. See, you're more interested in the money part. How much is he going to charge me for parking? Very good. So you see, one person is looking for that. How many of rest of you thought that this is the most important thing? The money part. So parking successful. See, parking successful. In English, why not in Telugu? Right? Why do you expect it to be in English? See, the moment you do a language-based communication, you fail half the time. Imagine if there was a 11,000 volt electricity and instead of the board it says don't touch. They put a skull and 2 bones. Everybody all over the world knows you touch this, that's what you will become. Right? So nobody goes there. So how can you make a symbol communicate? A tethering symbol maybe, right? A tethering symbol. But it should be known that I have successfully acknowledged that you have the right to park here. There is no error. Okay? And your time is now this much and this is the cost. Because you're parked in a peak hour, so the cost is more. Or you're parked in a non-peak hour, so your cost is less. So this whole information, if you can communicate, okay, without confusing, you've done a great job. So that becomes a very big challenge in the Internet of Things, getting the user experience right. I found this in one of the parking lots in Singapore. You're driving the car in, you can see from the car at the top there is a red light. Wherever there is red, that means there is no parking space. But wherever there is green, you can go and park there. So the moment you park there, the green becomes red. And it all adds up to the front where there is a board which says 5 parking spaces left, 3 parking spaces left. Okay? But that communication is still external, it's still not Internet of Things. Right? The moment it integrates with your parking fee, the moment it integrates with knowing where you are at what time and so on, then it becomes Internet of Things. So technologies. So what are the testing times that we will face? The technologies keep changing. So you'll have to be at least reasonably aware of what's happening in this and how you can keep in touch by being part of the forums and so on. And even though the product takes years to develop, they become obsolete in months. Okay? So constantly becoming aware that this is a possibility and seeing how you can still maybe not be one step ahead, but at least be in step with what is happening. And this concept of they are designed to be fragile, so why test? Let's not do too much of regressive performance testing. It's going to work for 3 months. If it works, whatever, like, I met someone and they said that the cost of replacing is cheaper than the cost of testing. So you might as well build some product and then say, I'll replace 10%, it's okay. If it fails, I'll simply go immediately and replace it. That's cheaper for me than building an exhaustive test environment and so on. It may hold good for, say, when you're in the scale of thousands, but the moment you reach the 100,000, 200,000, 1 million scale, then the testing is much, much more cheaper. And building the design to last longer is much more cheaper. Right? So robust by design then makes more sense. So test-driven design in the Internet of Things is the most important aspect. So what happens therefore is that the ones who are in the testing profession, you become as important or more important than the person who thought about the idea as well. Because you'll have to define and say whether it's going to work in the real world or not. And so test-driven development becomes a true requirement in the Internet of Things. Right? And then replication of the user environment. How are you going to replicate the user environment? And in the flat world, how are you going to replicate? For example, I went to Mongolia a couple of years ago and I ended up being there in December. Right? You know what's the temperature there in December? Minus 34. If you open your gloves and use your phone for 5 minutes, you won't have your hand after that. The hand will simply fall off from your hand. It'll just fall. It will break and fall. It's so bad. You can't even open your gloves. I couldn't use my phone there. I had to come inside the car, open the gloves, use the phone, again go out. You can't wait in the street for somebody with your normal, touch screen phone. It doesn't work. Because it doesn't work with the, what is that called, gloves. So you see, replication of use. So if you're planning a product here and you never get a minus 34 scenario, okay, and if you're planning to sell a large number of phones in Mongolia, you won't be able to replicate that environment. So that becomes a challenge because there's a flat world today. Right? I know because I had a company where we never sell a single phone in India. All our phones are sold in Europe, in US, in South America, maybe in the Middle East a few, in all the oil wells, okay, but we don't sell in India. So my biggest challenge here has been to get my team of designers and developers and testers really understand the end user. What are they undergoing? What are they going through? So I show them a lot of videos of how it's being used. I get my sales and support staff in the US to record the videos of their usage and show it to them. But it's still not as good as replicating the actual environment. So 50% of my budget many times is travel of my people for 3 months, 4 months in the areas where it's going to be used. Because they go sit there and do the testing, make sure it works, and then, because you do testing with 10, 15 phones, we end up selling 50,000 phones in that area. There is always a concern and balance between privacy and convenience. Right? So there's you should do this search in Google. A lady by the name Kashmir Hill. I wonder how she got this name. Kashmir Hill. So there's a story in Forbes where she actually tracked which were the houses which had already implemented Internet of Things. She hacked into them and switched off the lights. She hacked into them and switched off the lights in live. She called them. She says, who are you? I'm from Forbes. I'm doing a research. I got your number. The provider of your products told me that you're a customer. So now I'm going to switch off your light. So which one? The living room light. She says, don't be kidding. I switched it off. She was sitting 2,000 kilometers away. From the internet, she hacked into that network and switched off the light. Right? So that story is very interesting to read. So that's a big challenge because what happens is that you get so sick and say, who wants to put a password here? Chhod do isko. Right? You end up getting into that thing, Gone are the days where you put really difficult passwords. My funniest moment was when my colleague who was in support, he went on a Friday and installed a system and then in one of our customers and went for a holiday. Those were days that there were no mobile phones. Saturday morning we get a call. Says he set up the system and gone, but we're not able to use it. So he didn't have a password. He didn't tell us a password. So we apologized, and then Monday when he came, we fired him. We said, you went on a holiday, you never told them the password. He said, I told them the password. What's the password? I don't know. I said, you don't know the password? No, that's the password. So when they asked, what's the password? He said, I don't know. So they thought he didn't know the password. Okay, but he put the password as I don't know. So the client lost 2 days of work because it was not so easy password to remember. And today, there are hacking algorithms which can easily find out whether it's a combination, this one, that one. So you never know. And I have a lot of friends who are hackers, they say, if they were not ethical, okay, they can become millionaires very soon. Because half of them are not using, or they're using passwords which is so easy to guess. They can just run, okay, an algorithm which goes and searches for all the people in Facebook, and the combination of names of their close friends, relatives, friends, everything. You run that algorithm, they get the password. It cracks. And it's difficult for human beings. The more information we get, the less our memory is. How many of you can remember 54 numbers? Tell me. Can one of you remember 54 numbers? I knew 200 phone numbers just 7 years ago. I don't even know 10 now. 7 years ago I knew 200. 10 I don't know. Not even 10. Why? Because you're so dependent on these devices. So this is something that's a big challenge, because unless you recreate this and make it secure, it becomes difficult. Second is testing in one location, supplying to the world. Third is the moment you become Internet of Things, then you're talking of having these devices with people who are going to only use the words, how I wish. They're not going to be able to explain to you anything else in any other term. They'll simply say, I wish I could do this, this, this. And your device must be flexible so that you can make that happen. Right? And somebody's working on that. There's a company called ThinkSpeak. Right? So you can actually order that product to tell you what it needs to do, and it tries to understand and build the controls that way. Open system need versus business driven consideration of companies. This is what is driving piracy. A lot of us don't want to pay because we feel it's not worth it that much. The business need of companies that they want to lock you. I'll never forget Compaq, laptops. They had very unique power cords. You couldn't buy anywhere else but Compaq. And what was the cost of the power cord? 5 times the cost of the other power cords. Was it rocket science? It wasn't. It was designed in such a way that you can't put any other power cord inside. HP printers. The ink is designed to dry, so that if you buy and if you don't use it for a month, you have to throw it, the cartridge. They needn't have done it. They're doing it because of business consideration. So I think the same will happen in this field also. Right? There will be a lot of companies which will take the first mover advantage and then try and block you and lock you to it. But I think it's time they learn that it won't work. Many companies which have tried it have gone and eventually ended up not succeeding as much as they would like to. So this home smart kits from Iris, it's like that. More driven from business considerations, pretty expensive, but it works very beautifully is what the end consumers say. So what are the tools and techniques that we can be prepared for and use? The problem is that how do you shoot a moving futuristic target? You're not really sure how this whole field is going. You know it's going to happen, but you don't know who the players are, what the technologies are. Right? And you have a gun that's a generation behind. Right? So you don't have something to test something for the future. Right? So keeping an open mind is very important. I know everything is going to make sure you lose everything. Like my brother was saying, which was very surprising for me. That's a very amazing thing of the West. He says almost all the people who come to get trained from him are at least 10 to 15 years older than him. And he's 40 years old. They are like 50, 52, 53. They have decided that, if I don't do, then somebody else is going to get my job. So they come for the training programs for all the latest technology. And they're all 50. They've been programming in the COBOL mainframe days, and they still want to learn now because they have to keep up. So therefore, if keep an open mind, anything that's happening and contributing to the future is a possibility that you can keep up with the moving futuristic target. Models of also, a lot of you are running companies in testing, a lot of you are working for companies which are doing great jobs in testing. So you'll need to look at innovative models. Crowdsourcing is one model that's talked about. I still don't know how monetary models can be built on this, but crowdsourcing, free products, pay per use, so you can, get the products free, and then, so it's like people don't feel cheated. You don't buy a high value product. You buy it, right, one time, but you only pay for use. For example, say an internet modem. Today the modem itself costs 1,500 rupees. But slowly now companies are realizing people are getting scared to buy the modem because they can't use for any other service provider. So companies are offering that if you buy 4 GB package per month, right, and if you commit for 6 months, then this product is free. So okay, fine, I will use 4 GB for 6 months, so let me take this, I'm not going to pay for the product. So like that, free products, pay per use, and taking risks and replacing faulty ones. So you say, okay, fine, let me give a commitment that we'll replace faulty ones. So this calls for understanding of, what are you testing for? So when you take a product and test it, what is the report that you can give? This is superb, it will be at 6 sigma levels, or say this is good, but for every 1,000 devices, 2 or 3 will fail. Are we as a company okay to live with it? So you need to make that call, right? Because maybe replacing 3 is cheaper than reinforcing systems, a lot of systems, to make it 6 sigma. There was this example which I read, about a Sardarji's factory in Punjab. I believe the Japanese, because there were a lot of boxes which were going unfilled with equipment, so they built a image processing X-ray device and so on, and it would constantly take the X-ray of boxes that were empty, and if it was empty, it would stop it and take it off, so that empty things were not supplied to the consumer. The Sardarji, what he did, I believe, he went and took a transfer of technology from that company, and he just put a fan. So it was an empty box, the fan would push the empty box down, and the rest of them which were not empty, because it was heavy, it continued in the conveyor belt. So he only, and it is a real true story, so he only spent 1,000 rupees, and that Japanese company had spent more than 2.5 lakh rupees for that product. Because the person went to the root cause. What is it that I don't want? I don't want an empty box. So how can I throw an empty box from a conveyor belt? Push it out. How can I push it out? Put the fan speed in such a way that it cannot push a heavy box, but it can push a light box. Whereas the other person was saying, I need to find out whether it's empty. This guy was not saying, I don't need to find out, I need to push it out. So just the word difference of wanting to find out and wanting to push it out saved lakhs of rupees to this person who took the transfer of technology from that company. So this, innovative models of taking that risk of, yes, I know it will fail, but it's okay. 3 failing and replacing is cheaper. Generic open source labs run by unbiased organizations, right? So that, there is no worry that, this is tested, certified by this open source lab. So this product can be bought. It will happen. Slowly the alliances will start forming and so on. So I've been seeing for the last 20 years how the alliances work in the West. A lot of ulterior motives. Okay. Yes, all of you must have experienced that. I think if we start taking that initiative and if we start working together, because they say that as a community, the Asians have a better feel of working together because we are anyway diverse. I mean, India is the worst example. 150 dialects, 15 languages, and you're all working in the same company. You need to communicate to each other and so on and so forth. So you will automatically have the diversity built in. So maybe we can push for these open source labs and start establishing them so that we become centers for excellence. So what are things that help? What is it that we need? Sound fundamentals in data communication. I just established a 200-seat office and I got networking and communication done. I was aghast that the consultant was using electrical tools to build a 50 Mbps connectivity. I said, what are you doing? You can't simply connect the cable and expect things to work and so on. There are tools like advanced tools from Tektronix which actually capture the data flowing in. It identifies where there's a fault. I said, if you quoted and if you're not using this, I would not have given you the order. I said, you find a person who can do this properly and give me the data and give me statistics. Only then I'm going to make you payment. You can't claim yourself to be a state-of-the-art networking consultant and use tools which are generation behind, right? So sound fundamentals in data communication. What is data? How does it come? How can you capture it? All of this is so critical for the Internet of Things. So data structures, visual display principles, communication I talked about. User scenarios and user experience principles. So making sure that you get your user scenarios right in every single aspect becomes very, very important. So this calls for an open mind. This calls for you to be able to give up your fixed idea. It calls for you to go sit with the people and say, I'm open to you to saying anything. Let me see how you are planning to use this product. And that was a very good talk we had about autism this morning. You heard it, right? They said they have attention to detail and they're straightforward and they're going to say this is wrong. They're not going to get scared, oh my, what will my boss think? So they'll be frank about it. So we need such people to make sure you get the right user scenarios and user experience. And then because the Internet of Things is economies of scale, so large volumes of data, so you better learn statistical quality control. Fundamental principles of SQC. You know, why you feel you need to take a certain decision, not on the basis of I feel so, I think so, but on the basis of accurate, validated statistics. Okay? So this field of statistical quality control becomes important in the Internet of Things. And standards, right? Right now no standards, but it will happen, and I think right now we have an opportunity to contribute to the standards. So become part of these things, start talking about it, go to Twitter, go to all these places, comment on the Twitter pages, communicate with the experts. You become an expert yourself, contribute to the machine-to-machine standards. And then simulation labs, because eventually if you want to create and make sure it works, unless you have a lab setup that will start making it work. You know, long ago, I think Computer Point, right? There was somebody who started these labs in India. They wanted to show the networking, connectivity, ATM, I mean, what's that? ATM, right? Some technologies of connectivity, networking. They made a lab. They showed how it worked. They showed the speed and so on. Today we have cloud-based products, but you know, these labs are really important if you want to make your product successful. Okay? So these are a few of the things that we can, as a community, prepare for the Internet of Things and beyond. Okay? So I had this much to share with you, and I hope you found it interesting. I hope you found it useful. Thank you very much for your time and patience.